Let's look at an example of collaborative filtering. Let's say we're interested in predicting movies. You have a list of users, Frank, Greg, Hillary, Joe, and they gave different ratings to movies A through F. And the rating goes from 1 to 5. So one question could be, what movie would you recommend Frank? The idea of collaborative filtering is you're going to find similar users to Frank. So if you compare Frank versus Greg, you'll notice that Frank and Greg rate B, C, and F quite similarly. Now let's check Frank versus Hillary. So if you look at movie B, for example, Frank gave it a high score, Hillary gave it a low score. Movie C, Frank gave it a high, Hillary gave it a low. So in those two examples, they're almost rating it completely opposite in terms of the ratings. There's also cases where Hillary watches a movie and Frank doesn't even watch that movie. Now, if you look at Frank versus Joe, for example, so Frank and Joe, perhaps B, C, and F, it's close, but the ratings are much more different than Frank versus Greg. So what ends up happening is you're going to say Frank is quite similar to Greg, given how close their ratings are. And you're going to look at movies that Greg recommended highly. So Greg recommends or rated G highly. We saw Frank did not watch movie G, so we're going to actually recommend movie G to Frank. Some additional concepts to consider or look up offline is sparse matrices, where you might have a lot of empty values in your matrix. You can also use this exercise to find similar items, for example, similar movies to F. And then lastly, you can also look at matrix factorization as an extra material.